Hello, I have one of these IBM power adapters. I've been using it for years to power one of these universal chargers. It's quite nice to have around for various types of batteries. And this old laptop adapter fits nicely. So it's from an IBM laptop, something from the mid-90s, I think. We can have a look here. IBM, so output, well, I'll take 100 to 240 volt input, 50-60 hertz, output 60 volt, 2.2 amps. So that fits really nicely with this charger because it will take a maximum of 18 volt. So that's a little bit too little for modern laptop chargers. So this one fits very nicely. And it's interesting to see it's made in the UK. I guess it's from a time before everything was manufactured in China. Anyway, unfortunately, it stopped working. So I want to have a go at opening it up and see if there's anything we can do to fix it. On the side here it says tested 9739. So that's probably the 39th week of 1997. So it's quite old. So I managed to get it open without too much cosmetic damage. Seems like there were just a couple of glue dots inside here. It wasn't actually glued down very hard, and luckily it isn't potted. Quite a compact design here. So let's have a closer look at it. Let's try to get it out of the shell here. So it looks like it's been conformal coated here. It's probably a good idea because when you've been carrying your laptop out in the cold and you come back into the hot office and you plug it in, there's probably going to be quite a lot of condensation. So conformal coating looks like a good idea. So let's have a closer look at the board here and see if we can figure out how it was designed. First we have the mains coming in over here. And it looks like, well, there's a fuse in here. So that's probably the first thing to check, see if that is okay. And then it looks like we go through a thermistor here. And it goes over here, so there's a filter capacitor, there's a choke. And then we have a bridge rectifier over here. And then it looks like it goes into the primary side filter capacitor. That's quite a large one, that's all the way across here. And after that, things get a bit more complicated with all these components we have here. So might have to remove this shield or see if I can bend it. I'm not sure what kind of switching controller is in here, but hopefully the switching controller is okay and it's something else. Because considering the age of this switch mode, it's not likely that controller is easily available. So if we're going to try to draw the front end, it's looking something like this. So we have our mains coming in over here. First thing goes into is a fuse. And then we have a thermistor. And then we have filter capacitor. And we have a couple of resistors across the capacitor here, probably to discharge it. And then we have a choke. Something like this. And then we go into the bridge rectifier over here. And then we go into the main filter capacitor. So I think it's worth it just to check this part first, see if there are any problems here. The obvious first thing to check is the fuse. We'll just get a meter here. So let me see. Fuse goes from these two. No, unfortunately the fuse is okay. We can also check the choke here and see if it's okay. Yeah, it looks fine. And let's check the main filter capacitor. It says 111 microfarad. Don't know if that's correct. I cannot see the markings on it. But it sounds reasonably correct. Now we can check the thermistor as well. Now it looks fine. And actually we can check the whole flow here. Yeah, it looks good. Yeah, no problems there. So the problem has to be somewhere under this shield. So I think I'll try to see if I can remove this shield without causing any damage. Okay, I managed to get the heatsink shield off here. Even there was only one solder point here, it was pretty tough to desolder because it just conducts heat really well. So it really needed a lot of heat to desolder that. Anyway, now we can have a look at the switching controller, and it says STR71504. Don't know if you can see that. I need to try to find a data sheet for that so we get some idea what's going on. Unfortunately, it's not possible for me to find a data sheet for this Switchmode controller. I couldn't even find a schematic using this controller, so we're going to be working a little bit in the dark now. I did, however, find a few places where they were selling these controllers, but everywhere there was a link to a data sheet. It was just a link to a search on alldatasheets.com. Anyway, so we do have a few electrolytic capacitors over here, plus our main primary side filter capacitor. So I think we should do an ESR check on those, because that's often a problem in Switchmode power supplies. So let's start with the main capacitor here. Let's say 220 milliohm, that sounds good. We have some smaller ones over here. 1.5 ohm, maybe a little bit high. That's a 47 microfarad capacitor. And we have one here in heatsink. Comes out 1.6 ohm. I mean, it's not horrible, maybe not so great, but not horrible. 0.06, that's the output filter, that looks good. The other output filter capacitor, 50 milliohm, yeah, that looks good. And we have one more small one over here. 2.4 ohm. That is a much smaller capacitor. Yeah, I'd say 10 microfarad capacitor, so that's probably okay. These are 470 microfarad. Don't know what this one is, but I don't see any of these ESR values preventing the power supply from running. So the electrolytic capacitors are all good. I think there's one thing we can try here is to inject a DC voltage and see if we can force it to start switching, or at least see if we can get something happening. We can measure maybe on the scope or see if anything happens on the output here. So I'm going to hook up a power supply here across the main filter capacitor. So the reason I do it like this is because it's much safer to work with than hooking up the mains power here. By using a bench power supply, we have very fine control over the current limiting, so nothing is gonna go wrong. So everything is very controlled, everything is very safe. If we hook it up to the mains instead, it's a lot more dangerous because there's a lot more power, and if we short something out, it's gonna be explosions and flames and components going everywhere. So this is much preferred method. Also, it's much safer. So usually you would expect there would be something like 350 or 370 volts, something across this capacitor here. But most switch mode power supply can start up at a much lower voltage. Some will start up as low as like 20 volts or something. So I'll just try dial it up and see what happens. And I've connected a meter here to the output, just in case it does start switching. Okay, I'll switch on the bent supply now, and I'll just start dialing it up. 10 volt, 20 volt, 30 volts, still not. Oh, something is happening now. Just at about 30 volts, it actually started switching and we get the correct voltage here on the output. So that means we might have some kind of intermittent fault here. I think I need to check it for maybe cracked solder joints or something like that. I mean, it does go through a lot of heat cycles and it gets quite hot when it's running. But it appears the switch mode controller is working okay. Okay, I've gone over the board and I've resoldered pretty much all the solder points. Some of them did look a little bit suspicious under magnification, but I didn't find anything super obvious, but sometimes it can be very hard to see a cracked solder joint. So what happens is part of the board is going to heat up and it's going to expand, and then when it cools down it's going to contract, and you get many of these cycles over the years, and that can result in a cracked solder joint. So I hope that's what happened here, but I would have preferred to find a faulty component like a bad capacitor, bad resistor, something obvious, but cracked solder joint is quite common as well. So I'll put it back in the case, hook it up to the mains and run some tests on it, put some load on it and just keep it running and see if it's stable. I've hooked it up to the mains and I hooked up a load on the output and a multimeter here across the output so we can see what voltage is coming out. So these resistors here should give a load of approximately 1 amp, so about 50% of the rated output of the power supply here. So I'm switching on now, see what happens. It's looking good. So I'll just leave it like this for a while and see what happens. So it's been sitting for an hour now. The heatsink over here is pretty hot. It's like hot, you can almost not touch it. The power adapter here is warm, it's not super hot. The voltage here is pretty much the same as when I left it. So it's looking good. So hopefully I can get a lot more mileage out of this little power adapter here. I guess it wasn't the most exciting fault finding, but that's just the way it goes sometimes. Thanks for watching. I hope you enjoyed the video. Give a thumbs up if you did, and subscribe if you haven't subscribed already. So I'll see you next time. Bye bye.